right, so today we're going to talk about application problems with arithmetic and geometric growth. So our first situation, suppose a balloon is filled with 5,000 cubic centimeters of helium. It loses 1/4 of its helium each day. How much helium will be left in the balloon at the start of the 10th day? So in this case, our initial condition is 5,000. It's losing 1/4. So but we want to know how much is left. So if it loses 1/4, three-fourths is left. So this one is geometric. And so on the start of the 10th day, we take our 5,000 times 3/4 to the 10 minus 1. And if we use our calculator to figure that out, $5,000 times 3/4 to the power of 10 minus 1, which is 9, not 99. That wouldn't be good. And we see we would end up, and I'm just going to round to the nearest whole number, about 375 cubic centimeters of helium at the start of day 10. So there's one way you can use, that would be obviously a geometric progression. Yeah. So let's take a look at one that's arithmetic. So suppose a trolley stops at a certain intersection every 14 minutes. The first trolley of the day gets to the stop at 6:43 a.m. How long do you have to wait for a trolley if you get to the stop at 8:15 a.m.? So the first thing we want to do is figure out how many minutes it is from 6:43 until 8:15. So I know if I add 2 minutes, I get to 6:45. Then 30 more minutes will get me to 7:15. And if I add another hour, that's 60 minutes, gets me to 8:15. So it's a total of 92 minutes. So I know, and this every 14 minutes. So we're adding 14 minutes every time. So we're going to let 6:43 a.m. equals 0. And that's going to be our starting value. We go 14 minutes for every n-1. Okay. I have to think about that first. If that's 0, actually, I think we can leave this as 14 times n. So we want the first stop. So when, yeah, so when n is 1, yeah, no, it is n-1. So when n is 1, we get 0 plus 0. So that's what we want. Sorry. I'm going to distribute the 14. And solve. Divide by 14. Now, what this will tell me is the number of stops that the trolley has made to that point at this certain intersection. So 106 divided by 14. So it makes a little bit more than 7. It's in between its 7th and 8th stops. So n is 7.5 whatever. How will this help me? Well, I know it's 92 minutes from the time it stopped first till I get to the trolley stop. I'm going to take the whole number value here and plug into my formula. So 14 times 7 minus 1 14 times 6 is 84. So there were 84 minutes between the first stop and the 7th stop. And then I got to the bus, to the trolley stop. And I know that it had stopped at minute 84, which was 8 minutes ago. So one way to do this would then be take our 14 minutes minus 8. I wait 6 minutes. which to me, that's a bit of work. Another way you could do this is you would know that you will get picked up on the 8th stop. So you could do your 92 minutes. You could do 14 times 8 minus 1. This would mean that at the 98th minute of the trolley's run, it'll get back to that stop. Subtract, you get the same answer. You get the 6 minutes. So it's just whichever method you prefer in this case. This one's a little more direct. Sometimes it's a little bit easier. So 7 application problems for your homework. And then we'll move on to exponential functions starting tomorrow. Graphing tomorrow as well, so keep that in mind.